Hello friends, welcome to Multiverse, and today I will be talking about something called dark matter stars. And I'm sure most of us already know what is dark matter, but for simplicity and understanding, I will explain the properties of dark matter in this video. So stick around friends, and also we are live right now across all social media platforms. So if you have any suggestions or any comment, you can interact with me live, and your messages will displayed on the screen, and I can address you with your first name and last name. So let's proceed to understand why we need dark matter stars, and what is so special in these dark matter stars. I think the first question is why we need dark matter. You see, what happened is that when we started exploring the cosmos, and we found that Earth is not the center of our universe. In fact, Earth is like many other planets which are scattered across the galaxy, and because of this there are other galaxies, and there are trillions of stars in each galaxy. We found that. So while examining these things, we came to know that the scientists have been about 100 years back came to know that the material which is in the galaxy, especially on the outer side or outer edges of the galaxy, is moving very, very rapidly, very fast, and it is moving so fast that the centrifugal force in those objects will basically throw them out of the galaxy. In other words, the gravity of the galaxy is not strong enough to hold the stars which are on the outskirts of the galaxy, and that was quite a baffling situation. And that means the gravity of the galaxy has to be more in order to hold these stars which are moving very rapidly, especially on the outer side of the galaxy, to stick around in the galaxy. And based on the calculation, we found that there could be some material, or the mass of the galaxy may be 5 times the mass that we can calculate based on the visual calculations, visual inspection of the galaxy. So when I say visual, it's basically the stars and the material that we see floating around in the galaxy, and count them by numbers, then also calculate their mass, and that will not account to the force required in order to hold the galaxy in a spiral form. So therefore, based on this calculation, the scientists came out with a assessment that the mass that we see is not sufficient to hold the galaxy, and there could be more mass lying around everywhere in the galaxy in order to hold these stars back, and that mass will then generate extra gravity to create that balance between the centrifugal force and the holding, the binding energy or the binding force of the galaxy, which will make sure that the stars are sticking around in the spiral, very neat spiral form. However, since we do not get any evidence, visual evidence of this extra mass anywhere in the galaxy, and therefore we do not see this extra mass anywhere in the galaxy, therefore we call it dark, because we cannot see it. And that is how the dark matter term evolved, because there is extra mass which we cannot see. And then further, we do not even notice any reaction going on. I mean, we do not see any extra mass lying around in the galaxy, but we also do not see any sort of X-ray or any sort of interaction going on because of this extra mass, other than just feeling the effects of its gravity. Then there are other challenges, other mysteries of the universe, which is around the supermassive black holes. Now, what are these supermassive black holes? Supermassive black holes are millions of times the mass of sun. Usually when the star is like 10 times the mass of sun, it will become a black hole, which is basically a star-like mass, a smaller black hole. And for all these different black holes to combine and form a supermassive black hole, we know that the universe started only 14 billion years back, and this 14 billion years time is not sufficient to form such large black hole. I mean, basically all the black holes must get together and form these large black holes. And as per our estimate, there are these large black holes in the every galaxies, in the middle of every galaxies, and these black holes are trillions of mass of the sun. So this is another big mystery that we have not found any answer so far, and that is how these large black holes, which are huge, they are trillions of mass of sun, could form in the such short period of time. So the scientists are now trying to answer these couple of mysteries. First, related to the motion of the star in the galaxy, they are moving quite rapidly, and second, the formation of supermassive black holes, and they're trying to find answers of these mysteries, two mysteries in the dark matter. And dark matter is something that we do not see, and we do not even detect the dark matter. So why we are unable to detect the dark matter? You see, when there is matter, which is electron, proton, you, me, whenever there is an interaction, there is an exchange of energy. Say, for example, if electron collide with another electron, it gives out a photon. So we see that this reaction is happening, and we are able to see the light which is emitted by that reaction, or some sort of radiation, either an X-ray or gamma ray. We know that some interaction is going on between two particles of the matter, and hence we are able to see these activities in this space. However, we already know that there is 5 times more mass that we actually see, and hence we call it dark matter. The dark matter does not react with each other, because if it had reacted with each other, we would have seen some sort of celestial reaction, some sort of particle traveling and telling us about these activities happening everywhere in the galaxy, but we do not see. So the deduction of the nature of dark matter is very strange. Dark matter is very heavy. It does not react, or it does not have any other way of communicating with matter or with itself, other than providing extra mass, which results in gravity. So that is why we do not detect any dark matter, and we do not know how the dark matter may look like. In fact, for sure, we are still learning. We just call it dark matter, but there is no way to even experiment and find out the properties of dark matter. We can only speculate and theorize. So this is where we are today, and we do not know too many things of most of the matter, which is including dark matter, exist in our space. And the chances are that nearly out of 30% matter of this space, only 5% is a visible matter, which you and I are made of, and rest of the matter is dark matter, which we do not know anything about. And now it has been theorized that dark matter, if it exists, plays a major role in bringing together the matter itself. So dark matter creates more gravity, which actually brings the matter, which is electron, proton, atoms, and all other things together, so that the clumps of matter can be formed. And dark matter basically creates that environment where the matter can be formed and start glowing, because when the matter is coming and increasing the pressure, the thermonuclear reaction happens, and you have the star. So the birth of star, birth of galaxies, if there was no dark matter, the matter as we know it today would have scattered evenly, especially when they are so less in numbers. Only 5% of the matter that we see forms our galaxies and planets and stars and so on. So if there was no dark matter in our universe, the matter would not have come close to each other and created this environment which forms stars and planets, etc. So dark matter is responsible for basically creating all the structures that we see in our galaxies, and it is a prime material which helped creation of universe as we know it today. And at a larger level, we know that universe is very, very large. At a larger level, the dark matter must have created these filaments, the kind of picture I'm trying to show you here. And these are the streaks of dark matter which comes close, and wherever there is excess dark matter, you see these points where the galaxies are formed. And this is how the universe was created, because of the dark matter. If there is no dark matter, wherever you see these dark patches, there is no light, there is no matter, there are no stars, there are no galaxies. So fundamentally, dark matter is responsible, the excess matter which we cannot see, which we cannot feel, and it does not react with us. So as this point in time, the dark matter is passing through us without even touching our atoms, or does not react with any of the material that we have. It has very exotic properties. The dark matter may pass through Earth and Earth will not even feel about it. So these are very exotic properties of dark matter. That means it is there, but it does not have any implication on the way we feel our nature. So the dark matter filament would have created a scenario where wherever there is excess dark matter, the galaxies would have formed and planets and stars would have formed. Now let's come back to the main topic of the dark matter stars. Now it has been theorized that to start with, when the universe was very hot in the initial stages after the Big Bang, the most of the matter would have been dark matter, because the matter formed after, we know that the matter formed after 300,000 years after the Big Bang. And then further down the line, the matter got converted into antimatter and matter, and then later on became protons and neutrons and electrons, and that's how the genesis of atoms happened. And that is what we see, when we look around all over the place, especially the visible matter. This is what it is formed. But we already know that there are excess matter in the space, and now the scientists are theorizing that this dark matter would have also got accumulated in lumps, and that would have created a scenario where the dark star would have taken birth in the early parts of the early formation of the universe, when the matter was still scattered and the universe was still cooling down. So dark matter would have come together to create huge lumps scattered in the space, and these lumps would be many times the size of the large stars that we see. In fact, these dark stars would have been very huge, maybe much bigger than the ultra massive black holes. Now, as per the theory of the scientists which has been proposed, these dark stars would not glow, because the dark matter does not react, does not create any other sort of interaction with it itself, or with matter for that matter. So it will not create any sort of thermonuclear reaction. It will be an accumulation of huge body of a dark matter. Instead, it will be cool, it will be dark, because there will be no emission of light or anything like that. Another point is that these dark matters would have attracted a lot of matter. The 5% material that we can actually see would have got them on the surface of this large lumps of dark matter, and the matter would have got some sort of pressure, and hypothetically the dark star would look like that, because the matter which are smeared on the surface of these dark star would glow in gentle blue light, because of the very mild heat which is generated on the surface. But overall, these are not stars that we know today. The stars are very powerful, they generate a lot of heat and trillions of degrees of temperature. These dark stars in the early part of universe would not have created any heat for that matter, but these stars would have played a major role in bringing the matter together, and gradually the dark matter would have dissipated, and this matter would have created the early stage, stage one stars, which burned very rapidly and exploded into supernova. So this is how the dark matter stars would have looked like. But imagine if the dark matter stars were not there, the current day stars, which is the stage 3 stars, would not have formed. So dark matter was responsible, or dark matter stars were responsible for starting the genesis of the universe itself as we see and as we know it today. And as per the theory also, the dark matter would have also created these, or would have been instrumental in creating the supermassive black holes, which are in the middle of every galaxy as we look around and we see. So I think we have no proof of saying that the dark matter star would have existed sometime in the antiquity or the early part of the universe, or even today. Dark matter stars would have been there and floating around, and we have no mechanism to even examine these dark matter stars and really understand the nature of the dark matter stars. But one thing is for sure, scientists now theorize that there would have been dark matter stars in the early part of the universe, which would have been instrumental in creating the galaxies and the star systems as we know it today. So friends, today's subject has come to an end. If you have any suggestions and any comment, you can send us your message. I always keep waiting for your messages, and I respond to each and every one of your messages. So as always, thanks for watching, and I will meet you same time next Thursday with another interesting subject in the multiverse. Bye bye for today.